temperature of the room. So they can fine-tune their display with the environmental setting, so you get a really good experience with the TV. Or the graphic designers. When they use something, they want to make sure that the color is perfectly matched. So they use a RGB sensor, because all of us don't have the same eye profile, vision profiles. Everybody has different. And of course, in the lighting space. In the lighting space, they use ambient light sensors to measure the amount of light in the room, so we can dim the light. But moving forward, people are using RGB color sensors to set the mood in the room. When you come into work in the morning, for sure the companies want the fluorescent light, so that the fluorescent light you can focus. But when you go to a restaurant, for example, it's usually a warm light, it's an incandescent light. The restaurants never use a fluorescent light, because fluorescent light is boring. So maybe when people leave the company, I want to switch to incandescent light, so people leave, they're happy. And the optical sensor space. So when we look at a phone, it's an ambient light sensor, and at the top of the phone, usually behind the glass, it takes amount of light, increase, decrease brightness to save power or to read the phone. But as you see the specs, like, it is getting really demanding. 6 years ago, people were happy with 1 lux sensitivity. The definition of a 1 lux is, I have a candle at 1 meter away, so that's a 1 lux. Right now, we have, most smartphones is 0.03 lux. And going forward, like, people are asking for 1 millilux sensitivity in a mobile device. What are you going to do with 1 millilux? What happens is that the aesthetics, the industrial design really drives this component. So they want to hide these sensors behind the black glass. The proximity sensor. It detects the presence, very basic function. Turn on display, turn off display. Used to be 2-3 centimeters, right now 3-4 centimeters. John showed a great video of the Sony's, like the hovering. It's only happening at 1 centimeter. What if you have the next generation 8 to 10 centimeter proximity sensors? Then you can have a really nice user experience with your phone at the top, almost 8 to 10 centimeters. But what are the problems with these sensors today? They are point functions. They only do light detection or proximity detection. Or what if my phone is like, when I pull out from my pocket, it already knows there is no object, so it can turn on certain functions. These kind of extra functions with these sensors, you can add value. Plus, the other thing is, like, we need to have more flexible solutions. I think all the sensor solutions, phones, they have fantastic processors, gigahertz, 2 gigahertz, but they consume lots of power. You want to do some pre-processing. You want smarter sensors. Like, my human body is smart. You know, for example, I do pre-processing in my fingertips. When I touch something, if it's not hot, it doesn't do anything. But when it is really hot, you do the processing here, and it sends the interrupt to the brain, and you pull it back. So the sensors need to do some processing. They need to get smarter and smarter. And for sure, we want more sensing for integration. So just to go over some basic functions, like when we say digital light sensors, these are transparent packages because they need to sense the light. The light has to go through the package. So when we say low power, this is our first device, 0.65 micron. This is less than a micron. So which means you can operate these devices all the time. You can register the light all the time. And the thing is, innovation and integration. I think it applies in most of the MEMS sensors and like the pressure sensors. The challenge with the sensor is the dynamic range you're addressing. For example, light sensor, like we've seen like 0.1 millilux to 65,000 meters. It's almost 26 bits. No one is going to put a 26-bit ADC in an optical sensor and is going to pay $20 in the phone. It won't happen. So you need these different modes of operations in the sensors. So the best solution is to have this like almost like a automatic gear in your sensor, so that the sensor does all the computation without interrupting your application processing. So with our ambient light sensor, we can do that, and it is the only ambient light sensor in the market. And when I talk about integration, I'll show you a part that we integrated 6 sensors in one package. And also, like, the footprint is really important, the thinness is really important, because the optical sensors, the challenge is the MEMS, the touch, maybe they can handle flex, or they can handle the main PC. The optical sensors, they have to be at the top of the phone. So which means it's the most expensive real estate on the phone. It is thin, it's getting thinner and thinner, it has speaker, it has all those sensors. So the size really matters here. And let's go forward. Going to the RGB sensor. So what if I give you this, a color spectrometer, which is probably a couple $1,000 in the market, but if this thing is in your phone, what you can do with this thing? So this is where the market is going right now, from ambient light sensing to the RGB sensing. So we can sense all these functions. we call true color sensing. It is smarter ambient light sensing. You know, I talked about the ambient light sensing. The biggest problem is this getting false interrupts from the infrared light or UV light. But when you have an RGB sensor, you know the components, you know the IR content, you know all the RGB content. You can get a really nice RGB calculation and get your really good lux value. Another thing, the richer color display. So you know, the iPad announcement, the latest one, they talked about almost like 15 minutes about iPhone. It's about the quality of the display, the retina display. Okay, I have that fantastic display. I'm under fluorescent light or I'm under incandescent light. How am I going to differentiate it if the device is not smart enough to sense the environmental lighting condition and to adjust to that? Because human eye is very responsible for two main things, contrast and brightness. As long as you provide those 30 bits, 40 bits, a human eye can sense that. We can really differentiate two different screens. And the other thing, you know, probably like many of you were at MWC 2 months ago, there was an announcement of 85 smartphones. So if you look at all the smartphones, you know, they all look the same. It's a display with a black bezel. That's it. There are some smartphones that are white bezel, but you have those black lines on those phones. And people go to stores, we pay $40, $50 to get pink cases, you know, yellow cases, because we want to customize these products. We want to feel, you know, personalized, you know, this is my thing. But in that case, we haven't seen colorful phones yet in the market today. The RGB sensor enables that, because when you have a color glass, color bezel, when the light penetrates through, the light phase is going to shift. You have to compensate for it. The ambient light sensor is not going to work. You need the RGB sensor there. So this is what we did. We're integrating 6 components, red, green, blue sensor, with an IR sensor, with a temperature sensor, and with a proximity sensor. It's all in a 2x2mm package. It's still the smallest package, thinnest package, and all this function together. And as you can see, people were asking for 1 millilux. We can today provide 1 millilux sensitivity with this sensor. This part is going to be released in a couple of weeks to the market. So we'll see what other innovations can be done with this part. And the RGB usage cases. Now we talked about detecting the color temperature. I mean, there is no need for your lighting control system. You go buy a device, you plug it into your wall, you pay $500 to a company. We already have smartphones. If the smartphone has an RGB sensor, it will sense the lighting condition, it can adjust to that. And it is my smartphone. When I go to home, it's going to set to my settings. If somebody else comes to my house, you know, girlfriend, somebody, it can set to her settings. The other thing, detecting type of light, this is a big deal. Fluorescent light, incandescent light, sunlight, halogen light, they all have different spectrum. If my device is smart enough, I'm in this room, that's in an office space. It is fluorescent light. We're sensing light, but we're not sensing any infrared light at all. It means I'm inside the building. So with this very basic function, you can easily identify you're inside or outside the building. So you can turn on or turn off certain functions. Maybe you can increase the power of your GPS, or you can decrease the power of your GPS, or some other things. Or you can sense the frequency of light, 50 or 60 Hz. If it is 60 Hz, I can easily say I'm in North America. Color bezel devices we talked about. And the auto white balance adjustment. This is a big deal also. The cameras today do the white balance adjustment on the software level. They don't do on the hardware level. So when you take a picture, even if 5 megapixel, 8 megapixel, it is not perfect. So you need to do auto white balance adjustment, and this is the best way. And the other application that you can do with the RGB sensor, you can check the pulse rate. You can also check the pulse oximetry, the blood oxygenation level. So we're going to biometric applications. Another fantastic thing, if you have a light source next to your RGB sensor, you can start sensing the color of any texture, any object. Because I have a personal story with this part. For years I debated with my mom, with my girlfriends, like this shirt is blue, this shirt is green, you're inside a store, or they say, oh, it's because of the lighting condition. When I was getting my driver's license, I realized that I was colorblind. So I'm glad that we're releasing this RGB sensor to the market. Thanks a lot. Yeah. So let's quickly show the part that will release input fluids. Okay. The thing is, you can always challenge me. I already have a front-facing camera, so why do I need an RGB sensor? You need an RGB sensor because your camera consumes almost 200 milliamps when it's operated the application processor. This part is 20 microamps, 10,000 times less power. Camera doesn't have dynamic range, the biggest problem of camera. It's not going to have 1 milli sensitivity. It's not going to have sensitivity up to 65,000 lux. With this part, you can do that. So it can operate all the time. So just show you the basics, like maybe you can see the blue light or the green light coming to the part. Let's give some red light. Red light, the stick detector. And maybe let's see it. Wow, I'm being really cool. Thanks a lot.
Awesome. Thank you very much. So this wraps up our first 3 presenters. We've covered some exciting space here, from motion sensors to touch, what's ahead, touch, world, and optical sensors. We are running about 12 minutes behind schedule, which is not too bad. So we're going to, as I said earlier, take a quick break, maybe 8 minutes, and we'll be back here 5 minutes to 8. Please be sure to check out all of our demo partners, particularly those that are in the back and the side, and we'll all come back here. The restrooms, unfortunately, in the main hall is closed. The 70 probably closed up that area, but there's a restroom right outside. So I'll just read this.
Fine.